In the last class, we discussed about volumetric, we discussed about different elastic constants. So in today's class, we discuss about volumetric strain and bulk modulus relationship and how we will derive the relationship between volumetric strain and bulk modulus. For the first, we will see the volumetric strain, how we will derive volumetric strain. For example, in case of a solid body, there is if there is acting of sigma x, sigma y and sigma z. So if I take my axis, this axis as z axis, this axis as x axis and this axis as y axis, so the load acting upon the solid body will be on this direction it is sigma z, on this direction it is sigma x, and this direction it is sigma y. Okay, so if I want to write the total volume, so the total volume is, this is L, this is B and this is H. So the total volume will be L into B into H. Now the solid body total volume is L into B into H. Now the change in volume, the volume change will be delta V will be delta L into B into H and delta B into L into H and delta H into B into L. So why this change in volume became this? Because whenever the body is extended, whenever the body is elongated, there will be change in the length, there will be change in the breadth, there will be change in the height also. So that's why the change in length will be delta L into B into H, delta B into, so here D is nothing but the change in length, delta B is change in breadth, delta H is the change in height. So whenever we divided with this volume, so whenever we will divide this volume, whenever we divided with this volume delta B L into B into H, so delta B into L H plus delta H into B into L, so separately by LBH, the total volume. So now here BH gets cancelled and here LH and LH gets cancelled and here LB and LB gets cancelled. Now we will left with delta L by L plus delta B by B and delta H by H. So from here we can understand delta V by V, change in volume by original volume, is nothing but it's our volumetric strain, and delta L by L is our change in length, that is EY plus delta B, it is B, this direction it is B, so EB nothing but it is X direction and in the Y direction it will be EZ. So from here we can understand EX plus EY plus EZ is our volumetric strain. From this we can understand that volumetric strain is sum of the strains in individual axes. Okay, from here we can understand that so if we want volumetric strain, we need to calculate the stress in strain in x direction and y direction and z direction. The summation of all these three strains will give us the total volumetric strain. So let us calculate for this body, this is y, this is x, this is z. So this is the x direction, this is y direction, this is z direction. From this we can return it as, if there are three stresses acting on the stress of a body, then we can write it in sigma x by E minus in the x direction. The x direction will cause lateral strain in other two z and y directions also. So that lateral strain will be sigma x into E minus sigma x into E. From this we will get into sigma y equal to, strain in y direction, mu into sigma y by E minus sigma y by E. This is the lateral strain caused by the stress in the direction of sigma. So next, strain in the z direction will be sigma z by E minus mu into sigma z by E minus mu into sigma z by E. So let us simplify this. So when we take out the sigma x by E, the equation will become 1 minus 2 mu, because there are two mu's, minus mu will become 2 mu. So sigma y by E is also in the similar way, it will become in this way, sigma y by sigma z also will become the same in 1 minus 2 mu. If we summation for the volumetric strain, we need to sum up all these things. So let us sum up all these things. So then I will get sigma x by E into 1 minus 2 mu plus sigma y by E into 1 minus 2 mu plus sigma z by E into 1 minus 2 mu. So in all these 1 minus 2 mu is common. So from that we can get by E into 1 minus 2 mu is my volumetric strain. So whenever I will take this volumetric strain down, the equation will become in this way. So whenever I write it as E equal to, can I write it as sigma x plus sigma y plus sigma z by volumetric strain into 1 minus 2 mu. Can I write this or not? Can I write like this or not? So I can write this, because here if the three loads which are acting upon the solid body, if they become only sigma x, that is sigma x equal to sigma y equal to sigma z equal to sigma, then the whole equation will, all this equation will become sigma plus sigma plus sigma, because the only load is sigma. Okay, so 3 sigma mu into 1 minus 2 mu. From the bulk modulus definition we will know the change in pressure by volumetric strain is nothing but it is our bulk modulus. From that we can understand that E equal to 3k into 1 minus 2 mu. So this is the one of the standard relationship between bulk modulus and the Young's modulus and Poisson's ratio. This is a relationship between elastic constants. In the similar way, we can get another relationships between shear modulus and mu. So mu is our Poisson's ratio. Okay. So sometimes Poisson's ratio will be written as 1 by m also. Okay. We need to understand it. So if we equate these both things, we will get E equal to 9 by 3k plus n. So n is modulus resistivity, k is bulk modulus. So in this way that there are different equations we can understand. So there are different types of, this is our volumetric strain and this is the relationship between bulk modulus and the volumetric strain. So in this way we need to understand the bulk modulus and volumetric strain relationship.